Hey, hi, everyone. A warm welcome for everyone for our EA Global Summit 2021. And this is Mohammed from the organizing team. So before we start, as a part of an organizing team, I would like to thank everyone for your interest and joining us for the session. So this session is all about bringing structures into models where the deeper insights will be shared by Han van Roosmalen, okay, who is a Sparx Enterprise architect. About Han, even on his birthday, he is there to take you much deeper on the topics here. Okay, so it's to be informed. Okay, so we will be muting all the participants throughout the session, and if there is any queries during the session or after the session, you are welcome to post it on the chat box. So once this session is completed, you can reach the presenter on the dedicated Teams channel. So additionally, if you would like to collaborate and communicate, you can do for next 1 hour. The presenter will be staying on the Teams channel. And if you have any difficulties, you can just drop us an email on registrations@eaglobalsummit.com. And thanks again for your interest and the support. And this, I'm handing over to Han to proceed further. Okay, perfect. So Han, the stage is yours. You can start now.
Thank you, Mohammed. Welcome everybody to this presentation. As I said to Mohammed, it's still a bit warm because I added the last notes 5 minutes ago. So it's a work in progress, and everything I do seems to be a work in progress. I will talk about the use of design structure or dependency structure matrices for helping you understanding systems and or applications. So the subjects that I will discuss today are: what is a design dependency structure matrix? I can imagine that not all of you have ever seen a dependency structure matrix, so I will show what it is, and I will tell you how it can help you in understanding a system or an application. I will also show you how you can use dependency structure matrices for better structuring of applications and or your EA models. And I will show that you can combine EA models with your actual source code in a single dependency structure matrix. And one of the advantages of that is that you have an integral traceability over your model as well as your code. The world we live in looks like the picture on the left. When we put that into a matrix, it's more easy to understand, but you can go as far as Microsoft did with MFC, and that is not how a DSM or a system should look like. Who am I? I am Han van Roosmalen. You can find me on LinkedIn. I'm one of the 3 amigos of eXpertise, and I hope you will find time to see their presentations as well. We all have different backgrounds, so our presentations are very different from each other. I work with the EA since version 6, and I work with DSM since 2003, and I gave various talks on dependency structure matrices at various worldwide conferences. What I do for a daily living is providing consultancy and training to my customers, and currently I have 2 parallel activities, the one bigger than the other one. Currently I help a large data modeling team at Dutch Railways for creating a better EA model, and I work for Hearing Holland, a smaller company where I help the product manager designing system configurations and product lines. On the right, you see myself and a capuchin monkey. I'm not sure why I put that picture in place, but I do have something with capuchin monkeys. As you might know, capuchin monkeys are real wild animals, and they are the most intelligent monkeys on the planet. They're less intelligent than apes, like orangutans and gorillas, but they are very smart. And sometimes I think we have a lot of capuchin monkeys in IT. Dependency structure matrices and models have to do with complexity. So what is complexity? In my humble opinion, complexity of a system, and the overall complexity of a system, is the product of complexity of the structure of the system and the complexity of the domain. If you rephrase it a little, then it's C system is C structure times C domain. I have to make a small side note because Albert Einstein invented the formula ESMC square, and I think there must be a square in one of the C's on the right side, and I'm not sure where. The domain complexity is extremely hard to change. It's very hard to change physics or governments that come with all kinds of rules and regulations and laws and such. Some domains are difficult to understand, to comprehend, and to model. So that's not where we can help with DSMs. Where we can help with DSMs and architecture is on the structural side. So we have only, in this formula, we have only one parameter that we can influence, for better or for worse. If we define and design a better structure, then the C structure will be less, so the product of it will also become less. And that parameter is influenced by the architecture. Lousy architectures have a big C structure. So what we have to do, what we have to achieve, is that we can get insight, control, and oversight in the architecture. The way we do that is with models, like doing what we do in Sparx EA, and with matrices. And in my opinion, an architecture is just a pattern of boxes and arrows. So what we do as an architect is drawing boxes and arrows in certain patterns. Some patterns better than the other. Maybe you've never heard of design structure matrices. They are around quite some time. The first DSMs the methodology was defined by Stephen Ebinger and Tyson Browning in the 1970s. And the method was used to create and design complex systems. The interesting thing about DSMs is that in itself, DSMs are not complex. Creating a DSM is not complex. So where DSMs are used for is, in many cases, a redesign of a complex system, or just a design, or a validation of the complexity. They can also be used by project planning and for traceability. In IT, DSMs are one of the most interesting means to move from legacy to microservice architectures and reusing code that is involved in those microservice architectures. There are many DSM tools for software development available. I named just a few: Structure 101 and Depend and Lattix. And you can find more information on the dsmweb.org website on other commercial tools. I do a spoiler alert first. Lattix is not free, but by far the best that I have found, and the only one that has connections to EA. Okay, the dependency or design structure matrix is in itself pretty easy to understand. Here you see a dependency structure matrix, and what you see on the in the column is the same as in the row. So the diagonal is the projection of the dependencies between the element itself, and this cross means that B has a connection to C, and C has a connection to E, and D has a connection to F. What you see in this DSM is that there are connections from top to bottom, but also from bottom to top. These are circular dependencies, and that's and it is proven that circular dependencies make understanding a system more difficult. Software system that has a lot of dependencies above the diagonal is very hard to understand and maintain. So what dependency structure matrices tools try to achieve is that by doing some calculations, they try to push all the dependencies below the diagonal, as you see in this matrix. So what you don't want is dependencies above the diagonal. And as you see here, this is a bigger system, and here there are dependencies above and below the diagonal. So this system is more easy to understand than these systems. Though this is a technical decomposition, and when we make a logical decomposition out of it, by putting the intended architecture in this matrix, then it might change a lot. To achieve or to help you getting better insight in the complexity of a system, DSM partitioning is a very nice way of working. Some tools provide, based on the numbers of the dependencies inside a matrix, can help you to automatically find components, elements that are interfacing with each other, elements that are closer to each other, etc. So partitioning helps us to do some ordering in DSMs. You can order them by hand, but sometimes algorithms can do it much faster than you can do. The examples that I show here are not the best examples that I will show you, but it gives an idea. So you can have software, system, or model DSMs, or the combination of all of them. A DSM, when you load a model or code into a DSM, it instantly shows you the realized architecture, or in safe terms, the emergent architecture. So what you want to do with a DSM is put the intended architecture in and read from a model or source code the emergent architecture. And what you will find is the degree of loose coupled systems and their interdependencies. So if you look from top to bottom, it can provide you a way to help improve your model or your code. It can help you to refactor code because you get a higher level of visibility of your system application than you can have with doing normal refactorings. A DSM gives you a higher overview than a model does because it overlooks your model. And I will show you in a minute how that works. But you can also look in a DSM from bottom to top. If you change an element inside a DSM, it will show what higher level elements or modules or system components are affected. So if you model your unit tests inside your DSM and you change a class inside you mark a class inside your DSM as changed, you will automatically see what unit tests are touched by that change. And if nothing is touched, then maybe you have to add some unit tests for that specific change. The interesting thing about EA and Lattix is that Lattix can read in EAP and EAPX files, and you can see Lattix as a kind of drone that flies over your system and shows the system at the highest level, but also can dive down very fast into details. On the left side, you see a DSM that I have loaded into Lattix of the EA example EAP file provided by Sparx Systems. When you look in the left matrix, it's very difficult to comprehend what is happening here. The only thing you can see is that the model seems to be scattered around and that there are some areas that are larger than other areas. So EA 15 examples and enterprise architecture make out 30% of the dependencies between the rest. There's the size of the dependencies. So those parts of the model contain the most elements and dependencies. So just by using the component partitioning algorithm, Lattix finds out that there is 1, 2, 3, 4 components. And it brings together the top 7 components that have a large interaction with each other. So it will see that as a single component. That's maybe not what you want in your model. Maybe you want only a smaller dependencies between parts in your model. Like here, in this area, there are no interdependencies between these elements in those packages of the example repository. But there are dependencies between, say, the core part of the model and the more leaf part of the model, here and there. This DSM is based on just doing calculations on the left part. So maybe it does not really represent your idea of the complete model as being fit to what you know about it. So in that case, you can move packages around and improve the way the DSM looks like. The interesting thing about Lattix is that when you make changes to your EAP file and you reread your project, it will keep the changes that you made to the structure in place and put the changes that were made in your model in the matrix again. Yep. I hope you get a bit of an understanding of what a DSM is about. When I drill down in the EA example EAP file, I find this diagram, and it looks like this in the DSM. So elements in this diagram are reused by other parts of the model, and there is an internal structure looking like this. And on line 28, you see that all the elements are on the diagram, but here you see the dependencies between the elements, and which are the lines in the diagram. What you also can see is, hey, there's stuff in the DSM that doesn't have any relationships. And if you start looking for this diagram, in this diagram, you'll find that they are empty. Not a very good example. So what I'm looking at when I'm looking at the component structures in a DSM is looking for elements that are below dependencies that are below and above the diagonal. So here you find 18 dependencies below the diagonal and 2 dependencies underneath the diagonal. And that triggers me because there is a reason for this. And I have to know why why this reason exists. So I found the 2 diagrams, and what you see here is that in normal situations, in normal modeling, in most of the diagrams and the models, there's a relationship going from a requirement to another element. But in this particular diagram, you find that there's an element pointing to the requirements. That's the opposite direction. So this too might be a modeling mistake. And maybe there are more of these kinds of inconsistencies. You can also use a DSM for traceability. And the interesting thing about traceability in a tool like Lattix is that you don't have to select one type of element and a package in the row and another type of package and element types in the columns. For Lattix, it doesn't matter. So you can easily see what element is connected to other elements. So what you see here is that requirement 110 has a relationship with an element in system engineering. So by looking at the requirements, you will find that there is traceability. But you can imagine that if you have traceability to something in software engineering, that might have a connection into your into another part of the model. So you can go from your requirements down to other elements just by following the numbers in the DSM. As I said before, you can also do some change impact, determine change impact. For instance, there is a test suite in the EA example EAP file called open orders. It has 2 test cases, list current orders and package orders. You can find them here. These 2 lines are these 2 ones. And if you go back in the DSM, you will find that these elements are linked to a use case called list current orders. So if you use open orders, the test case open orders for checking the list current orders, you know that you have this connection. So you can imagine that you create other test cases that don't have connections to use cases, or that use cases are missing, or etc., etc. So here I'm going from bottom to top. The interesting thing about using a tool like Lattix is that it can show you the intended versus the emerging architecture. So you can create your models to represent the intended architecture. For instance, component diagrams or other diagrams that are helpful to try to express what you try to achieve in your intended architecture. It's a good practice to use logical components for that, because your technical components will come from your source code or your data tables in your database. So the first step you do is load your EA model into a DSM, and after that, load the application files into the DSM. And then move the interesting application parts into the intended architecture that comes from your EA model. When that happens, you will see that the DSM will show you the result of this. So you can find out if an application is correctly structured. Does it fit the intended architecture, or was your development team like a bunch of capuchins and they went their own way? What areas in the software or in your model are complex and maybe you have to redesign them? What parts or what changes can you make to do significant refactorings? And if you intend to use your current software to move from your silo application to microservices, what can we use or reuse in those microservices? So what I did here is I created a very small EA model, a really small EA model that only has some diagrams in it, and I created kind of a logical decomposition of what this system should do. It's a system, an application that I found on GitHub that has the title Hospital CRM. But if you look inside the application, it's very small, but very helpful for this presentation. So what I did, I created the APX file and loaded it to the DSM tool. I also read in the C# code by reading the solution file from Visual Studio. And then I started this, and then I have two matrices in one. So this is the matrix of the Sparx model, and this is the matrix of the .NET source code. And now we are going to show what the intended architecture should represent and is resolved by the solver. So I'm starting to move those classes to components, I say logical components that I have modeled in my EA model. So I'm slowly moving code from my or code representations from my .NET model into my Sparx model. And you see that all kinds of relationships are going to exist between the EA model and the source code. So here I get some traceability logic. I can do that on various with various intentions, and that's a way to create multi-domain DSMs. So in the previous slide, I showed you a domain model of a DSM of a domain model and a software system. But I can also map requirements to modeled elements in EA and implemented components in source code. I can also map user stories to modeled elements in EA and implemented components or data tables. I can map my staff to modeled elements and components. So I can have traceability over multiple model sources. And that's where the fun starts. Here's an example of tracing requirements from the application. So I have defined a number of requirements into the logical elements, but because I dragged the technical elements from the source code, so the classes from the source code, into this part of the model, I instantly have the relationships between the model, the requirements of the model, the logical decomposition in the model, and the source code, and a mapping to elements or components in the software that map to system of technology elements. So what you see here is the requirements domain and the application domain, and this is the technology domain. Well, that's nice if you have created a nice intended architecture and you did move the software elements into your model part. Then you will find that there are dependencies above the diagonal. And here the work of the architect starts, because in this tool I can say, okay, I'm not allowing dependencies in this area or in this area or maybe somewhere here. So that means that when I read my EA model and my solution file, that it could be that dependencies arise in the next release of your software. And in that case, you're notified, hey, okay, there are some dependencies that are not allowed. So in that case, you find a reason for doing refactoring as fast as possible, because these numbers will grow in the meantime, because those capuchin monkeys are still working on software and they think they are doing the right stuff. So in this case, you can say, okay, dear capuchin monkey, please remove those dependencies because you're ruining the intended architecture. And therewith, the maintenance quality of this system. I give another example. Currently, I'm working for, as I said before, I work for the Dutch Railways, the Nederlandse Spoorwegen. And there, about 30 modelers are working on a data model that will fill the data warehouse of various business units within the organization. When I came in, all the people were working just in this area. And what we found out is that they changed each other's elements. There was no ownership of elements and data tables. They created all kinds of diagrams, and modelers found out that their colleagues were changing their models. And so the model that I worked on was changed by somebody else. And when I'm creating a data warehouse, that's not very handy, because at the Dutch Railways, we use the data tables in conjunction with the DDL generator of EA to create the data schemas of the data warehouse. So if somebody is changing my my data table for example, by extending it with an extra attribute, I might be in trouble because my load script will not be aware of that. So after a year, there was the urge to include ownership into the model. So what I created was a repository holding the various business units, and I had some people working on moving elements from this area, especially the data model root and the werkmappen, the working packages, the work in progress packages, to their own part of the model. And what you see is that these parts will be easier to understand than this clutter of a model. By doing so, it becomes easier to validate if a person is the real owner of an element or a data table, and it proves that when we did things like this, it was easier to deploy large data models into the data warehouse. So the goal is to achieve a repository for 30 plus modelers and 200 plus viewers that is easy to understand. And you can imagine that if everything is cluttered here, it's very difficult to understand. So what we want to achieve by the end of this year is that this part is gone and moved over to this part. And what you can see is the dependencies between the various clusters. And the ultimate goal is, because we can use this for a certain level of versioning, the ultimate goal is that we are going to use Lemon Tree for model versioning. And that is easier achieved on this kind of decomposition than on this composition. So when I go into the model, you can see that, for instance, for the cluster personnel, we use use cases or user stories in the backlog. We call it development, and the tables that are in production are stored in this part of the model. So what I see here is that there are dependencies between elements, data tables that are still in development, and data tables that are still in production. So this is from development to production. But on the other hand, there are tables in production related to elements that are still in development. So that makes it very interesting and very difficult. But this helps to see how far are we in moving from development to production. So what are the advantages of EA and the Lattix combination is that we have a way to have insight and oversight on large models. It's easier to determine the model quality. So what is the quality of your model? Is it a clump of all kinds of elements and diagrams, or is it a bit more structured or fully structured? It's possible to align modeling with development, and the examples I showed were about code. But if you have a database, Lattix, and you can make a connection between Lattix and the database, Lattix is perfectly able to read the data schema and show a dependency structure matrix on that. DSMs are not difficult to understand. You only have to get used to it. And I have trained a number of architects in DSMs, and they get the hang of it in a couple of hours, and they behave as very ordered capuchin monkeys after a day or two, and behave like humans again within a week. So that's a good thing. So it's not difficult. The learning curve of a DSM is pretty flat. If you want to do some refactoring of your model or your code base or your data structures, then you have a very good combination here. So that's very helpful. I found a very interesting hands-on picture on the internet made by David Turner that explains how some of the patterns in the DSM look like and how you can improve those patterns. So when you're interested in this, have a look at this URL. And this is the part that I want to talk about. I have maybe some time to give a demonstration of some things with Lattix NEA. I'm not sure. Mohammed? Or are there questions so far? Mohammed, are you there? Okay. Well, I can give a short demonstration of the latest example, the last example I gave. So here you see so this is the data source of this DSM. It's a EAPX file that I've created by reading in by moving a large SQL Server based repository into an EAPX file, and this is the DSM that's created from that. And what you see here in the user interface is these are the project root nodes in that model, and the next level is the views. So there are many for this. For instance, this business unit commerce has a number of teams underneath. I will focus into the team driving personnel. And when I go to the production part of it, it's part of the information architecture, then you see all kinds of objects, data warehouse kind of objects. And when I drill down, these are the data tables that are stored or are used for this team to develop. And these are the data tables in production according to the model. So what you see here is the relationships between the various data tables. And of course, you see dependencies above and below the diagonal, but if I do a partitioning like this, always nice when things change. Dependency options. I told you that the dependency options should be below the diagonal, but somehow I managed to put them above the diagonal. But what you see here is that the model itself, or the relationships between the data tables, are only on one side of the diagonal. So there are no circular dependencies in the data tables, which is a very nice thing to have not. Here you see at this level, you see that there are dependencies between the physical data model and the logical data model. So that are those dependencies. And those logical, well, I think this is enough to show. I can see much more when I look at this, but this is enough for now. If there is interest in more information about DSMs, please let me know. I can set up an extra demonstration in which I can answer your questions and show more information on the tool itself and on the combination of EA and Lattix. So far my presentation. Any questions? Hello?
Perfect. So, Han, I'm sorry, I have missed you when you asked me for. Okay, so I was speaking over the mute, and I have just noticed it. Yeah. Sorry. What was you asking for?
Well, if I can give more presentation, I can give another presentation which people who are interested in this methodology. But it would be better to have a kind of a team session in which people can interact with me and ask questions, because now it's one way. Now it's a one-way
conversation. Yeah.
Conversation, and that is not very helpful from this point onward, I guess.
I understand.
If there are any questions, I'm willing to answer them, of course.
Okay, so I think as there is no questions raised from the attendees. Okay, so I think everything is fine. Okay, so more probably, as we have the dedicated Teams channel, okay, so we see that like Teams sessions and Teams conversations are being helpful for the attendees. Okay, so we can move over there as we are nearing up like. Because we have another.
There's a question from Matt Thomas, which is how is an associated treated where there is no specified direction. That's right, but it looks at the source and target ends of the So Lattix looks at the source and target ends of a relationship. So even when you don't specify direction, it's implicitly specified by Lattix or by Sparx. So.
Okay,
because
cool.
Of the source target relationship. It says it's unspecified, but it's not really unspecified. But it means that those relationships in your DSM can end up in the above or below the diagonal in a reversed order. Yeah, that's a problem. So you have to find those relationships, and I hope there are not too many.
Perfect.
Okay.
So
I'd like to thank Klaas for his happy birthday wish.
Sure. So
and I'd like to thank Jerry especially. Yeah.
Perfect. So thank you so much for your presentation, and hope it is very informative to each and every one of our attendees. Okay, so just give me one quick minute.
Yep.
And I hope Matt have also received a clarification. If not, as we said, like
I will put it
he will be available
Teams
on the
also. So
Teams.
I will answer every question in Teams. No problem.
Hmm.
Well, thank you very
Exactly.
much, Mohammed, for the possibility to have a talk about Capuchin monkeys. And
Sure.
talk to you
Anytime.
later.
Thank you so much, and thanks again to each and everyone. Okay, so we'll be meeting you soon with another session as a host, and also like if you would like to uh, drop any feedbacks, or if you'd like to if you have any issues and if you would like to rectify it, then you are welcome to drop an email to registrations@eaglobalsummit.com. And if you would like to need more clarifications with regards to the presentation, and if you'd like to communicate and collaborate with Han, okay, so you are welcome to do it on the Teams channel link. And see you all soon. Thanks again. Thanks, Han. Thanks for the presentation. Yeah.
Thank you very much. Bye bye.
Bye bye.